table, let's talk a little bit about lab reports. So the way lab reports are going to work in the physics classes here is that you are going to, you're going to be writing up lab reports. There's always that boundary between how much of this needs to be independent and how much of it is working together. And you can kind of work together all the way through all of the measurements, all of the calculations, double check each other, make sure that you're being very careful, stop by office hours, and ask whatever questions at all you need to understand what's going on. I mean, I'm everybody's lab partner in some sense. So for the lab reports, when you write these up, they really should be written up independently. So you should be writing up your own lab report, and writing up the lab report, that's part of the course, is writing all this stuff up. Now the format that I'm going to suggest is to start out with the title and the objective. And that shouldn't be too difficult. What will happen each week is that we'll have a title and we'll have an objective. So I'm gonna write those on the board. Those are all going to be on the board. They're going to be written right up there. You're welcome to just use the title and objective that I've provided. If you want to put a little more detail into the title and objective, that's fine, but I'm perfectly fine with just the title and objective as written. Now, I think the format that I prefer personally is once you've written down the title and objective, go ahead and get the results. What that does for the reader, which is probably me, is that you've stated what you set out to do, right? Here is my objective for the day. This is what I got. So I set out to measure densities of some metal samples. Here are my metal samples, and here are the densities that I measured. Now, the reason I prefer that is because once people can see your results, then what they can do is they can start to formulate questions. I wonder how the results turned out to be this. And then as they read through, this is, again, my personal preference, as they read through your report, then they can start to see how you came about, how those numbers came about. So you don't have to do that if you want to put the results table at the end instead. I know that that's a common format also. Now, in addition to the results table, I do want, maybe a sentence or two, just a comment of what happened in terms of the results. So, and a very common example of what you might write would be something like, all of the densities were within 2% of accepted values, something like that. Or you could say, all of the densities that we measured came within 1 or 2% of accepted values, except for the aluminum. And the aluminum was actually 6% higher than accepted, possibly a different alloy, something like that. Sometimes what students do in a lab report too is they'll, at this point, they'll say something like, yes, the lab was a success because we got whatever numbers. So a couple things to keep in mind here. Typically, in lab reports, typically you don't state it was a success or not a success. I guess that's the other alternative here. That's not something you have to concern yourself with so much as take a look at the results. The results table will have percent differences written in. And so whatever the percent differences are, maybe make a comment on that. Just comment on how large the percent differences were and what you think about why you might be seeing that difference. Another thing that I want to encourage students to think about is I always worry that students in their science classes have been taught that you're rewarded if you get the answer that the teacher wants you to get, but you're penalized if you don't get the numbers. And that too isn't really the way science works. So the way science works is, we do the best, most careful measurements we can. We carry out the calculations, we double check, triple check the numbers, and then once we've got the numbers, we just report those. So we're not trying to match numbers up with an accepted value. Now, accepted values can be useful to possibly catch, you know, some crazy answer we've ended up with. If we're off by a factor of 2 or 5 or 10 or something, then usually it's a units error or something like that. But in any case, think in terms of we just want to do the most careful numbers, and then we'll see what our results turn out to be. So now the results table, I guess we talked about percent difference here. I should give a formula. So for percent difference, what I'm going to say for purposes of this class is use this. Percent difference is taking the measured value, subtracting off the accepted value, dividing by the accepted value, and then multiplying that by 100%. So the way this is read then is it's read as the numbers we got are this many percent different from the accepted value. Now again, remember the accepted value might not even be the same alloy or the same substance, but we are going to do the measurements relative to accepted. Just, it's a useful measure to work from. Now, if I multiply that number, when I divide through, this is like a percent difference, when I divide through, the units go away. And so there are no units on a percent difference. And then I've multiplied the number by 100%. Now 100% is just the same thing as 1, so that doesn't change the numbers. So, you know, maybe I find out this is at 1.2. You know, maybe the brass I measure, and this works out to be 1.2% higher than accepted values. Maybe the aluminum turns out to be 3.7% lower. Go ahead and leave the plus and minus signs in there. That's fine. So plus and minus signs, if everything's coming out plus, it means that all of our densities are larger than the accepted values. If they're minus signs, then those show that we got numbers that are below what the accepted values are. All right, we've talked about this. So title and objective, results table, data tables. Now I make a big deal about units because units are really important. And then formulas. So any formulas that you've used in any of the calculations, those should appear in the report. So you should have the formulas. You don't have to show all the calculations. If you want to show a sample calculation, that's fine. If you want to show all the calculations, you could do that too. But in any case, make sure that the formulas are included. Now, it lists data tables and graphs. Today we don't have any graphs. Most weeks we will have a graph or two that you have to complete. So the data tables and the graphs, they need to be clearly formatted. If I've got graphs, I have to make sure that I'm labeling the vertical axes and the horizontal axes of the graph with the correct units, with the correct physical quantities. Everything needs to be labeled properly. And then finally, the lab report, limitations. This usually goes by the name of error analysis. So now in error analysis, again, this kind of comes back to the idea of what were the measuring devices that we used and what were their limitations. So I've written that down, like the direct measurements for this lab. The direct measurements are coming from the scales. And when I first wrote this up on the board, I was thinking the scales, more often the scales are within 1/10 of a gram of each other, but today, for whatever reason, they're not. We're going to have to boost that up. I'm seeing differences of like 0.4 or 0.5 grams. That's quite a bit larger. The calipers, ideally, we could measure those right down to plus or minus 1/10 of a millimeter, but it's not really that practical. So I boosted that up to 0.2, and even that's, we'll see. We'll see if we can really get the calipers measuring this accurately. So first of all, think in terms of the direct measuring devices that you have, and plus or minus how much in terms of units. Now, the other thing that should go into the limitations or into the error analysis are possible assumptions that we've made. Now, in today's lab, certainly one of the assumptions that we've made is we've kind of neglected the hooks. Now, I could take the hooks out, I guess, and do the measurements. Maybe I'll do that. When I've got a class full of students here working on this, I usually encourage them not to take these out because the threads are very delicate and they could get damaged. But maybe I will try pulling out the hooks today and redo the measurements with the hooks out. In the past, I've done that, and the hooks are less than a gram, I think. I'm going to take one out right now and see. We'll see. I'm being very careful. I don't want to break this. The hooks are needed for some other, we do a number of different property materials on these samples. Our metal samples, you're gonna. All right, so this came in at 0.9 grams. So this hook that's sticking out, I guess if we put this on here, 270.8. So now we have those, we have an empty place inside there, right? So we'll see. I'll have to decide which way I want to go ahead and take the measurements. When I do collect the data, I've got my paper, my notebook set up right here, so I can come in and start taking some data. All right. So those are the kind of things that you can include in the error analysis. You can include something about what assumptions are we making, and you can say that we've neglected the effect on the hooks. All right. Now, the lab reports are officially due 1 week after the lab. So by the time the next lab is starting, or the official start date for the lab, they're going to be due. Now, these should show up on Canvas, so you should be able to go to Canvas and take a look at the due dates, which come up, and the due date should be listed there. But in general, it's the week after. Now, in the lab itself, you're going to need to be able to carry out all the calculations. My policy typically in lab is before you can leave the lab, your lab group, you and your lab group, have to show me that you've taken all of the measurements, you've carried out the calculations, you've double-checked, you know all of the units that apply, and that you have roughed out the data tables and the results table. So everything's calculated. The idea is that when you go home from lab, the only thing left to do is write up that lab report. Okay. So questions on any of this? If you guys have questions on any of the stuff for today's lab, let me know. And again, stop by office hours and let's get any questions that you guys have, let's get those answered. I think we've looked at everything in a fair amount of detail. I've gone over the scales, we've looked at the calipers, so I think we'll just wrap things up right there. Again, any questions, stop by office hours.